Hello everyone, today we are going to do the AP level demonstration. This is a spectrum tube which can cause the gas in the tube to emit light.
And here is a split which can cause diffraction, and on another side it's a reflection lens.
This is a spectrum tube full of hydrogen. Now if we see the emitted light through the refraction lens, we can see that the light has been divided into a different colors, little line that create a spectrum.
So what if we change the gas inside the tube? What's going to happen to the colors that we see in the side? So now the tube is filled with helium instead of hydrogen, and by looking through the lens, we can see that the light is divided into more side of colors than hydrogen does.
Now the tube has filled with nitrogen gases, and we can see through the lens that the light has been divided into more sets of color. The spectrum is more completed than the tube was filled with hydrogen and helium. Now what caused these differences in the spectrum? In this experiment, when a voltage is applied to this electrode, energy is supplied. These energy are absorbed by the electrons, which make them excited to an upper energy level. From this excited energy level, the electron naturally wants to make a transition or relax back down to its ground state. When an electron relaxes from an excited state to a state lower in energy, a particle of light called photon is emitted. That's how we can see a light emitted by a spectrum tube. An electron may relax all the way back down to the ground state in a single step, like presented in 1. Or it can relax to a ground state in a series of smaller steps. Each step emitted a photon, like represented in 4. The energy each emitted photon, delta E, is equal to the differences in energy between the excited state E and the state which electron relax. In the equation, energy N equals to the energy of the excited energy level, and energy M equals to the energy of the relaxed energy level. The energy of the emitted photon determines the color of light observed, which satisfies the equation. In the experiment, different gases has different sets of electronic energy level, so they have a unique set of electronic transition. Each transition emitted a photon with its own energy and may be seen as a kind of color. So when an element has more energy state level, it has more differences in energy state, enable more photon with different color emitted, so we can see more color through the lens. This set of color is unique for each gases and may be used for identification.